Kubernetes is a way for you to orchestrate your microservices across a large fleet of servers, and it comes with a whole bunch of options and capabilities like autoscaling and resource allocation, which allows you to say this container right here will have only so many resources available to it, at which point either it needs to scale horizontally, and even with newer versions, it can launch larger scale horizontally, which gives it more resources if needed. You have full control over this capability in all of your microservices using these simple YAML files. You could even use additional plugins. One of those plugins that we use at PubNub is called Helm. You can write Helm charts and templates that will auto-generate all the manifest files that are required to launch your service inside of Kubernetes. And there's a lot to it. It's actually kind of detailed, but it has fastly and quickly become an industry standard that every cloud vendor supports today. Kubernetes is something that we have recently migrated to over the past, not too recently, actually. It's been about 3 or 4 years ago now. We started our journey to migrate over to Kubernetes, and it was a big challenge because one of the things you have to do when you migrate over to a microservices platform, you have to change all of your infrastructure to a container-based system using a 12-factor standard, and it requires you to orchestrate your software just a little bit differently. You have to add in metrics, logging to standard out, and you have to configure your charts in such a way that will allow your applications to run and even scale. Although you can bypass some of that and get to Kubernetes more quickly if you don't add a horizontal pod autoscaler or vertical pod autoscaler. You can keep things static and just launch the number of pods using command line tools. There you go. Kubernetes. At PubNub, we found ourselves in a successful situation migrating all of our service API components over to Kubernetes and running our infrastructure as microservices. It took us a while to do it because we have a lot of things to do in order to make that possible in such a way that allows us to autoscale on demand based on the current traffic workloads, and it's something that we did find a lot of success in. However, the moment we launched, we ran into some significant problems, and you'll probably run into similar scenarios, and these are the 3 scenarios that were the most costly to us. Yes, we launched into a setup that allowed us to scale and meet the workload requirements of our customers who use our API. We had the problems, we had some initial challenges here. Even though we are delivering our promises, everything's working well, we had a high cost, so we actually ended up spending a lot more money initially due to the configurations. Now, various cloud vendor providers like Amazon and Microsoft and Google, they all have dedicated Kubernetes runtime systems that make it a little bit easier for you to manage Kubernetes infrastructure. Some of these services are like GKE and EKS on Amazon. The challenge is, when do systems scale up, right? How fast do you scale up systems? Now that one's fairly straightforward because typically the Kubernetes system itself will hook into a plugin for the vendor based on how the vendors work in launching new servers, and Kubernetes will sort of control that scale up process. However, from a cluster configuration perspective, when you want to scale down, therein lies the problem because you have sort of a fragmentation problem with all your containers all over the different nodes that need to be relocated as things need to scale down, because you'll just have this distributed container fragmentation problem where some of those services still they need to keep running. However, when it needs to downscale, you'll still have running services on those new servers. So you have to relocate and do this sort of shuffling, and there's a rate at which that can occur that is non-disruptive. But at the same time, the default is very, very slow, which can take weeks sometimes, depending on what kind of scaling event occurred. And that's a little too long. So you can tune that in a way that is a little more swiftly migrating containers to other nodes and then rebalancing traffic that way. You can also say, coming along that was a steep learning curve that we had, because our whole team and every team needed to become aware of how Kubernetes works from a container-based perspective, how data routes to it, how allocations occur, what are the request limits versus a hard limit, when will it autoscale if you have a horizontal pod autoscaler enabled. Those are all general knowledge gaps that all the teams had to learn, and it did have cost from that perspective. So if you are looking to migrate to Kubernetes, it is absolutely worth it because you get a lot of control over your infrastructure. Just know that it is a steep learning curve in order to understand how these systems work together. Not all systems are treated the same, with optimizing horizontal pod autoscalers and having a good stability on those, whether you don't want them to like spin up a whole bunch of pods that, eat up all these resource allocations, but the system doesn't actually need it, right? So it's a balancing act. You need to figure out what are the right tuning settings. When does a trigger occur for the cluster to launch more pods, right? When does it know it needs to launch more hardware? These are things that you need to keep in mind. And some of the challenges we made at PubNub when we migrated over to Kubernetes, this scenario where we had under-optimized and over-optimized our pod auto-scaling policies in such a way that required us to tune up or tune down the resources that are being monitored to launch new pods to grow to demand, right? Because you need to scale up as needed. Kubernetes, we have some common first-time questions if you're thinking about moving your infrastructure over to a microservices system. Although it's 2024 at these stage, everyone is probably already containerized their infrastructure. And so it becomes, how do you orchestrate those containers? And Kubernetes is usually the one that's at the top of the list that you would choose. However, one of the problems with Kubernetes is it's vast, it's complicated, there's a lot of details involved, and it requires a lot of YAML files. You have so many YAML files. Of course, you could even go further and orchestrate automation of those YAML files all together and not have to worry about any of that. Infrastructure can be completely automated in another way. Generally, the challenge is, though, almost every application, they're not the same. They're different. They all require different resources and patterns that go along with it. You would want to give disks different kind of disk performance profiles. If you're thinking about ways of storing that data that is required to store data, different kinds of compute requirements and memory requirements, this is a challenge. So there are other options, but we're looking at Kubernetes today. So there are common first-time questions that you might have when you're looking at Kubernetes. And first off, it's actually really simple. What is Kubernetes and what do you use Kubernetes for? Kubernetes is a platform that automates containers. It automates containers. It doesn't have to be Linux. It can be any other container, right? Usually, there's no virtual machines here. When you're thinking of containers in Docker, for example, every operating system already has a way to provide isolation and restrictions around running applications. So there's usually a common pattern for every operating system that you can define a Docker container for, and it's actually running natively. There's no virtual machine involved for the most part. So what Kubernetes does is it essentially orchestrates those containers across a large number of servers that provides things like autoscale, redundancy, auto recovery when hardware failures, because that happens quite a bit, especially if you have a large deployment and you have tens of thousands of servers. Guess what? You're going to see several servers fail each hour, potentially. And that is a problem, and having a human have to go and recover that, you're going to run into, generally a lot of extra men. Your team will have to spend more time actually developing and maintaining an infrastructure, especially at scale. So that's what Kubernetes does, is it just sort of helps operate it operates your applications. It automates it all. It makes it really easy. That's why I love Kubernetes so much, because before Kubernetes, we had to go in and manually do a whole bunch of hands-on keyboard activities every single day whenever we needed to make changes or if there's hardware failure. Now, with a Kubernetes infrastructure, it takes care of itself pretty much for the most part. All right, so we're looking at some of the common first-time questions you have with Kubernetes. When you're switching over to Kubernetes, you'll have a checklist of items that you kind of want to go through, or maybe you're trying to understand a little bit more about Kubernetes. How does auto-scaling work in a Kubernetes world? Well, you get to write this manifest file. It's a YAML file that helps describe how a pod will be scaled upon. This is called HPA, the horizontal pod autoscaler, and what it's going to do is it's going to look at the current resource utilizations of those pods. By default, it comes with some pretty basic things like CPU and memory. Those are actually the biggest things that you need to scale on from a performance perspective, you'll need more CPU or you need more memory. And what the HPA will do is allow you to set a threshold saying this pod should only ever use this much CPU, like you can say one whole CPU or a fraction of a CPU. You can also say it can't go above a certain limit of number of CPUs, so you can actually overcommit on resources, right? So you can claim one CPU, but you can say it can burst to 2 CPUs. Then you have a third configuration option that says, at what point will it scale up? When should we add more pods to the cluster? It's entirely based on the amount of allocated resources and the current utilized resources. It looks at the resources that you've allocated, the request amount, say you requested 1 CPU, and then you can say at 50% CPU utilization, I want you to add another pod. So that way the CPU utilization drops down to 40%, right? And so it might pop back up to 50, it'll launch another pod, the cluster CPU average will drop down to 40%. And it just keeps doing this until it gets to, it tries to maintain a target resource utilization. So say it drops down to 30%, then it's going to say, okay, we don't need so many pods online anymore. Let's go ahead and destroy one of the pods. Gracefully, of course, right? We're going to take it offline, we're going to stop routing traffic over to it, and then we'll terminate it and then reclaim those resources for other pods to be used in the future. And this is the downscaling cycle. There are 2 important aspects to really pay attention to when you're looking at how Kubernetes deals with scaling down resources. These are actually 2 really big details, and they are very important to look at. The first one is the easy, obvious one. It's all based on the current running number of pods. Say you have 1 service, let's keep this simple. You have a Kubernetes cluster, it has 1 service in it, and the service has maybe 10 pods. That might be the minimum deployment. Well, you've set a resource usage setting of 50% CPU utilization. This is the target that the cluster needs to maintain. If it goes above 50%, then Kubernetes knows to launch another pod, so that way the resource average will drop back down to 50%. Now, if it goes below 50%, it will recognize that it might be time to turn off a pod, so that way we can reclaim resources and then get back to that 50% target of utilization. That part happens pretty quick. Kubernetes is pretty good at stepping in and taking care of the exact number of pods that should be online and using those resources based on the allocation. The problem is, though, depending on a spike of traffic, say your CPU resources burst up to 100%, you're going to need to launch a whole bunch more servers and then add a whole bunch more pods to all those servers. Now your target resource utilization is back to where it needs to be, and now you're able to meet the demand of your customers. The problem is, though, once you reach the need to downscale, Kubernetes can run into this fragmentation problem. It's a fragmentation problem. Your containers will start decommissioning themselves based on Kubernetes instructions, and this happens gracefully, right? But what happens is the servers are still running. You're still paying for the hardware, and Kubernetes might still have a few pods running on those systems. However, what Kubernetes now has to do is scale up a pod on where it has resources over here on maybe some older running hardware, and it can now start terminating those newer servers. However, that part happens pretty slowly. Essentially, this is sort of like a reshuffling. So the scaling down aspect can often lead to multiple days, which can end up being expensive. So you need to make sure to tune your infrastructure so that way it can better reallocate and migrate containers over to where the systems where you've got resources available, so that way one server isn't just stuck there with a pod on it, just sitting there servicing that one pod. It's really only using maybe 10% of the resources you purchased, and it's just for that one pod, just that one pod sitting there. So you need to be able to also configure Kubernetes to be swift about migrating pods and sort of packing the infrastructure the best possible way. So then it can turn off servers that it doesn't need, and you don't have to spend this extra money. In Kubernetes, there's 2 different very critical resource and limits allocations. They're separate configuration parameters. These parameters are very necessary for us to understand how they work, especially with horizontal pod autoscaling, and also how it can hinder or improve the usage of the hardware across the system. So there's a requests YAML configuration parameter in your pod manifest file, right? And in this requests sort of object, you have a CPU and memory setting. You can say that you want to request 1 CPU and 10 gigs of RAM. That's a lot of RAM. You probably don't need 10 gigs of RAM. You might need something like maybe a couple hundred megabytes of RAM. So say 1 CPU and a couple hundred megabytes of RAM. That request is going to be used in 2 very critical ways. One is that that request will lock out any other container from ever sort of eating into that request. So if you always request more than you need, then you're essentially going to be throwing away resources. It's actually better to request a little bit less than you need, and then your containers can more tightly pack together. And then as each container will potentially need a burst capacity, this is where the limit comes in. So you can set the limits. They also have CPU and memory configuration parameters. However, these are absolute limits. If you set the CPU limit to 1, it will never go above 1. However, if you set your requests to say 1/2 of a CPU, you're actually allocating and reserving that 1/2 of a CPU, but you can burst up to 1 CPU. And that's a pretty good pattern because if you have bursty traffic, and CPUs can be shared more easily across containers. Memory is another matter on that, of course, because memory, not all containers and not all systems are good about returning memory back to the system depending on your memory allocator. It's very possible that your memory will only ever grow. Usually it will stay static after a certain point. And so you kind of want your requests and limits to be a little more closely configured. Because the problem is, if your limit exceeds, say you request 100 megabytes and your application goes above that, Kubernetes is actually going to terminate the container, assuming that it went way beyond its limits, and it's going to kill out of memory. It's going to terminate that process, which is not good because that process is probably actively servicing existing customer traffic. So you still want to set a reasonable request, say your request is going to be 100 megabytes, but you could overcommit by setting your limit to 200 megabytes. So that way you've requested 100 megabytes, but you give yourself a little extra room, essentially double in this case, by setting the limit to 200 on the memory side. Then if your application needs 120, that's fine, because not all pods will always need that. And so now this allows your pods and all of your microservices to better utilize the resources, and it's more cost efficient.